Welcome to my video on how to build hash tables. This will basically be going over hash tables. Going to just reiterate some stuff from the previous lectures that we had mentioned, but going to enumerate them a bit more here. I do have a class over here that's on the side. That's just my reference for this when I've done it. Then I will be splitting this up also into multiple videos to make it easier to go through them. So right now we're going to go with the introduction and just the setup on how to build it. So remember, hash tables, we're kind of dealing with this three-part problem, okay? This three-part problem is as follows, that basically we want to get this constant time lookup for key value pairs, right? Okay, so in order to do that, the only thing we really know to do that's constant time for insert and, for putting things into it, for adding things is, arrays. Essentially, swapping out the values of arrays, it pretty much takes constant time. That's the only thing we know that's really constant time for collections. I mean, adding to the end of a linked list, yeah, but you can't just go and add into an arbitrary location. For arbitrary locations, you need an array, okay? So we need a really, really, really big array if we wanted to store all possible keys, but we don't have infinite space. So essentially, we've got three problems, which is that kind of just some of them fall from one another. So we need to transform an arbitrary key type into a number because, arrays don't deal with anything that's non-number, but that's nice. But the nice thing about computers is that everything's numbered, right? So we can take any arbitrary key type and we can turn it into a number just by, looking at it and going, okay, we need to, change the we can just take the binary in representation and turn that into a number. Now we have a number. That's not necessarily the best idea, but hey, it's a solution. But it's possible to do that. Now, how to do that is really hard. There's a lot of different things. We're going to show you in a bit in the next video about why choosing a hash code is important, a hashing function. But it's not something you should worry about in a 2000 level course. So you're going to use the hash code function that's built into Java that every object has. Okay, the second thing is that I mentioned is that if we're storing this in an array and we need, because we want the constant time, take something at our arbitrary index and update it, feature that these arrays have, we need a really big array. But we don't have space for a really big array, and what if I only want to store like 20 values in it anyway? So that's a bit troublesome. So instead, what we're going to do, of course, is what we do with like array lists, which is that we're going to use a small array underneath it, and then we'll grow it as we need it. Of course, this means since we don't have something infinitely large, right? If I take a key and I turn it into an integer, I need to mod it by the table size to make sure it fits into the array, right? If I've got a bunch of slots, say I've got an array of size 11, right? Then whatever unique integer I get out of here, I'm going to need to mod it by 11 so that it can sit at an index that exists in the array. Also, I don't have so that's problem 3. I don't have an infinite array, so two keys, right? 11 and 22, if they both get modded by 11, they'll end up in the same index, which is 0. Right? Two keys might have the same index collision, and we went over that and that's a collision. We went over that in the slides earlier. Specifically, we went over one of the ways in the slides on how to deal with those. So check out that previous video on it, but I will just simply show you the appropriate slide right now on how that was handled. Okay, so why didn't I have this open to begin with? I don't know, but I was thinking that at the very beginning, but okay. So the idea is that we take a key, we use the hashing function, and then we turn it into a proper index, right? And how do we resolve collisions? We use the open addressing, which is we compute the index by taking the hash code and mod by length, and then we can find it by and we can find where to put it, by looking for the next possible empty slot, right? So that's what this one was, right? So we had Tom, Dick, Harry, and Sam and Pete, right? And a bunch of them hashed to the same indices. Okay, right? So go back and check the previous video if you know about that. Chaining, the way it deals with collisions is very intuitive, right? I'll be programming the open addressing because that's what we go over in our exams this semester. But the idea for chaining is fairly straightforward, that each of these elements, each element in the array is a linked list. And so when you insert it into the linked list, you just simply add it to the, when you insert it into the hash table, you just simply add it to the end of the linked list at an index. And what you show is that basically these things maintain a constant length if they're evenly distributed. And then it takes a certain amount of time to look up, which we get into in later videos. All right. So those are the concepts that we're going over.